It is August 31st. This time next Monday, it will be Labor Day, and you don't have to come to school. And neither do I. Yay! All right, so August 31st. Graphs of motion. So the first thing I want to do is I need to define acceleration, because we're going to start adding acceleration into our mix of distance, displacement, speed, velocity, and acceleration. And what is acceleration? What does it mean to accelerate something? Nobody? Yeah, go ahead. Okay. Is it only when your speed increases, or could it also decrease? Would that be considered acceleration? Do you think? Probably not in English usage. Like when you're talking about it out there, not in my physics classroom, you probably only use acceleration for speeding up, for making myself go faster somehow. But in physics, we actually have acceleration, and acceleration is going to be any change in speed. Okay? And in fact, it's going to be change in velocity. So, acceleration is a change in velocity over some amount of time. Change in velocity over some amount of time. So we can write it as a formula. Acceleration is final velocity minus original velocity over time. So we're going to learn how to do 4 graphs, basically. 4 basic types of graphs. And the first one is motion diagrams, and then we'll do position time graphs, velocity times graphs, and acceleration time graphs. Because all that stuff varies with time.
Is that a formula?
That's an A. Sorry. My ink is running a little low, so it's a little not connecting very well here. There we go. Yeah, never hurts to ask. So, there are 3 ways to accelerate. You can. The one that most people think of is speed up. You can slow down, or you can turn. The last one is the one that nobody ever seems to remember. Speed up, slow down, or turn. Guess I'll put up my AP physics book for the day. You know you've gotten yourself into a tough class when your book has over 1,200 pages. That would be the Physics C book. But those kids are independent studies, so. And all the other teachers tease me because in physics, AP Physics, we count AP Physics 1, AP Physics 2, AP Physics C. 1, 2, C. It used to just be Physics B and Physics C. And Physics 1 and 2 were all one class. So I taught 30 chapters of material out of physics in a year. Yeah, it was a little like water from a fire hose. So they split that class up a while back. And then Physics C is the calculus-based class for the kids that want to be engineers. Okay, so acceleration. You can speed up, slow down, or turn. So I'm not going to worry about the turning piece today. We're just going to do the speed up and slow down. So I'm going to give you some descriptions, and we're going to give some motion diagrams that go with them. So, motion diagrams. These are the first kind. You will sometimes hear them called oil drop diagrams. And the number shown is the time frame. Dots represent the object. So there's going to be several of these that we need to learn how to do. And we're going to start with positive velocity and positive acceleration. And then I'll pause and let you guys get caught up because I know some of you are writing. So positive velocity and positive acceleration. Positive velocity means moving to the right, up, or forward. We consider right positive, up positive, and forward positive. We do that so we match up with math. So, positive velocity. So what would it mean to have a positive velocity? It means you're moving to the right. And acceleration that's positive is going to be acceleration to the right. And this diagram is trying to show, if you can imagine doing strobe lights. You know how when you watch somebody on strobe lights, it looks like their hands kind of jerk from one position to the other because you've just taken a photo and then it's dark or black and then you see them again a little bit later. And so you know that their arms are moving or their legs are moving, but it looks like they went freeze frame, right? It can be a kind of a cool thing to do. So what we're doing here is we're doing sort of the same thing, except we are doing this with oil drops. If you can imagine your vehicle or your object dropping little breadcrumbs behind it, or dropping little drips of oil out of its engine, which would be bad. If they're dripping, we're going to see where the car is located every time it drips. Okay? So what would this look like? Well, this one, if I put a 0 here, this is the time, and the dot tells me where I'm located. So if I'm positive velocity and positive acceleration, positive velocity means I have to move to the right. So my next dot, the next time I see my car, is going to be somewhere to the right. Maybe here. And I put a 1. And then I also have to do acceleration. So positive velocity and positive acceleration would mean moving forward and speeding up. So what should I do to show speeding up? Okay, speeding up would be going further distance, right? So my next dot should be further away than my last one, and my next one would be even further away than that. That would show me speeding up. So I see it's like you take a photo of me here, then 1 second later I'm here, then 1 second later I'm here, and then 1 second later I'm here. I'm speeding up as I go across. That kind of makes sense to you? Do you see what we're doing? Okay. So, what would positive velocity and negative acceleration do for you? What would positive velocity and negative acceleration look like? I still have to move to the right. But my speed needs to go down. So I need to slow down. So in this case, I'd start at 0, and I'd have a big gap, then a smaller gap, then a smaller gap, then a smaller gap. I'm going to the right, but I'm slowing down. Most people don't have any problems with those two. It's the other two that cause problems. It's the negative velocity and positive acceleration, and the negative velocity and negative acceleration that cause grief. So, negative velocity and, actually let's do positive acceleration first. Okay, negative velocity I have to start over here, because negative velocity I'm going to move to the left. And then we have to decide, are we speeding up or are we slowing down? I got to vote for speeding up. Anybody else want to vote? Y'all are so quiet. It's okay. You don't have to be loud. So let's go back to, what is acceleration again? Change in velocity. Okay? It's a change in velocity. So imagine with me for just a second, I have a negative velocity. We'll just make one up. Let's say you're going negative 20 feet per second. What would that mean? I'm moving backwards at 20 feet per second. And I have to change my acceleration by a positive number. Say +3. So if I'm at negative 20 and I change my acceleration by +3, where am I now? How fast am I going? Negative 17. And then I'll be going negative 14, negative 11, negative 8, right? You see what I'm doing? Acceleration is adding to velocity or subtracting from velocity. So Alden has told us we go negative 20, negative 17, negative 14, negative 11. Am I going faster or slower? Is negative 17 miles an hour faster or slower than negative 20? Well, negative doesn't make sense in that, right? Because in math you use signs for size, and here we use them for direction. So is 20 faster or slower than 17?
20 is faster.
20 is faster. And it's certainly faster than 8. So in this case, our object is moving to the left, but it is slowing down. It's slowing down. So we start with a big gap, Not as big a gap. Not as big a gap. Not as big a gap. Because the velocity is negative, but we change it by a positive number. We add to it each time. Positive acceleration means you add to the velocity. So if I have a negative number and add to it, it gets closer to 0. I slow down. The sign tells you the direction, not the value. It's going to be a hard fight with math. Because math, if I have negative 20 and I have negative 17, negative 17 is bigger. Right? Negative 17 is a bigger number than negative 20 in your math class. In here, it's you're going 20 miles an hour backwards or you're going 17 miles an hour backwards. 20 miles an hour is faster than 17 miles an hour. You're going backwards either way.
You could just think of it in the absolute value.
You can. Yeah, you can think of it as the absolute value. So, what does that do for our last one then? Negative velocity and negative acceleration. So yes, I've heard lots of good ways to think about it over the years, and that is one of them. Okay. Negative velocity and negative acceleration. Once again, I start on this side. And what do we do this time? So we start with negative 20 feet per second. And this time, instead of increasing the speed, adding to the velocity, instead of going negative 20 plus 3, negative 17 plus 3, negative 14 plus 3, now I do the opposite. Negative 20, take away 3. Negative 23, negative 26, negative 29. Speeding up or slowing down? Speeding up. So negative velocity with negative acceleration is speeding up while going backwards. So close together, further apart, further apart, further apart. If you want to put an example from real everyday life on that, this is backing out of your driveway and hitting the gas. You back out, but when you hit the gas, it makes you go backwards faster. The acceleration and the velocity are working together to move you backwards. On the two where you slow down, the velocity and the acceleration have different signs. They are working against one another. Okay? So those are motion diagrams. We're going to do position time later. Let's come back to those questions that I gave you to work, which you should do on your own paper and turn into me. So let's swap computers. And I'm going to